So let's get the derivative of 4 times square root of x plus 1 over x plus 5x raised to 4. So, you see, in this case, what we're going to do here is just use only one rule of differentiation, which is power rule. Why? Because this one, as you can see, they have their own variables, right? We have square root of x, we have x here on the denominator, and we have x raised to 4 here. So as you can see, these x's has its own exponent, all right? So let me rewrite it in a different way. So this one, it could be rewritten as the derivative of 4x raised to 1 half plus x raised to negative 1 plus 5x raised to 4. That's it. All right. If you recall your basics in algebra, then this is not basically a problem to you. All right. But to give you a gist of it, basically, square root of x is the same as x raised to 1 half. All right. And for this one, for the second term, 1 over x simply means x raised to negative 1. Basically, if you ever encounter a fraction in which they have x as the denominator, just take a look at their exponent of the x here. So as you can see, this is just x, right? So that means the exponent here is 1, so x raised to 1. So you can make it as a term in which you're not going to make it as a fraction, just like a whole term in particular. You can do it by reciprocating it. So from here, x raised to 1, then we could transform it into a whole term, but instead it would be x raised to negative 1. You guys get what I mean? Basically, whenever you see this one, 1 over x is equal to x raised to negative 1. So another example, if I have 1 over x squared, this means this is x raised to negative 2. All right? So lastly, if I have 1 over x raised to 3, so this is x raised to negative. All right? You guys get my point here? You guys get the points that I'm trying to point out for you? All right? Just take a look. All right? If the x is your denominator and you want to make it as a whole term, not a fraction, but as a whole term, you can do that. All right? As long as you have x as your denominator, and then take a look at their exponent. All right? So that's it. Now let's go back. So as you can see, each of the terms given in this problem has their own exponent. So if we see a variable that has an exponent, then we're going to use power rule of differentiation. All right, and this is x raised to n. So simply, if you have encountered a term that has a variable and an exponent, all you need to do is just simply bring down its exponent, copy the variable, and then the exponent above will be subtracted by 1. So basically what you're going to do here, again, copy the exponent, bring it down, then copy the variable, and then the exponent above that you used to bring down will be subtracted by 1. All right? Forgive me if I stuttered at that time. Okay? So let's do it here. So for the first term, wait. Okay, so for the first term, we have 4x raised to 1 half. So since this x has an exponent, so we're going to use power rule. So 4 is a coefficient, so we're not going to touch it yet, all right? We're just going to leave it as it is first, all right? So just leave it be for a moment. So now let's focus on x raised to 1 half. So by the application of power rule, what we're going to do is just bring down the exponent, which is 1 half, then copy the variable, and then the exponent you used to bring down will be subtracted by 1. That's it. All right? Next, for the second term, we have x raised to negative 1. So the same application here, we're going to use power rule differentiation. So just simply bring down the exponent, negative 1, copy the variable, and then the exponent you used to bring down will be subtracted by 1. And lastly, for this one, it's just the same application to the rest of the terms given here. So, similar as the first term, this term has a coefficient. So, simply don't touch it yet. All right. Then we're going to get the derivative of x raised to 4. So just bring down the exponent, copy the variable, and then the exponent you used to bring down will be subtracted by 1. All right. So let's now simplify. So 4 times 1 half is basically 2. All right. Then copy the variable. Then this one, 1 half minus 1 will give you negative 1 half as a result. All right. That's it. Okay. Next here, since we have a positive sign here, or basically an addition operation given to this problem, and then we have a negative number here. So what we're going to do is we're going to put negative here instead. All right. So instead of negative 1x, so what we're going to do here is just negative x raised to negative 1 minus 1 will result to negative. All right. Then for here, just simply multiply them together. 5 times 4x raised to 4 minus 1. So this would be 20x raised to. All right. So this could be your format of the answer, or you can just simply rewrite it this way. All right. You can rewrite this as 2 over x raised to 1 half minus 1 over x squared plus, plus 20 x cubed. All right, you can do that. Or you can simplify it even more. You see, if you recall earlier that x raised to 1 half is equal to square root of x, then we can just rewrite it as this way. 2 over square root of x. Then copy the rest of the given terms. So either of the three, the answer is still all right. So those are confused. How come that this x to half, sorry, 2x raised to negative 1 half became 2 over. If you recall earlier, all right, if you recall earlier that what do you call this one? If we have 1 over x is simply equal to x raised to negative 1, right? Do you recall that? The examples that I gave you early on before I proceed solving this problem is just basically the application for this one, all right? I made it into reverse instead. So, right, I have 2x raised to negative 1 half. So I can basically, simplify it in another way, which is this one, this x that has a negative exponent, I could turn it into reciprocal identity. So if we have a x that has a negative exponent, it's like, for example, -1, will be transformed into 1 over x raised to 1. Hence, if we have this one, x raised to -1/2, this would be just 1 over x raised to 1/2. All right, and the same application for this one.